Hi, my name is Shahir. Today, our group will present to you guys about our group assignment project for basic electric subject entitled Transformer. Firstly, I will introduce to you guys our group member. Firstly, me. My name is Wan Ahmad Shahir bin Ahmad Salahuddin. Next, Muhammad Koirun Ammar bin Muhammad Zuki. Next, Muhammad Hanif bin Jamil, Nur Ashikin binti Azman, and Muhammad Ikmal Mustaqim bin Badrun. Next, I will pass this presentation to my friend.
My name is Muhammad Ikmal Mustaqim bin Badrun. My part is objective project. Our objective project is to understanding the function and uses of transformer. The next, to seeking the working principle of transformer. The third one is to understanding the type of transformer. Next is to solve the calculation that involved in transformer. The last one is to know the application of transformer in real life. Background of our project is a transformer is one of most common device found in electrical system that link the circuit which are operating in different voltage. These are commonly used in application where there is a need to AC voltage and current by the use of transformer in AC circuit based on the requirement of the electrical equipment or device. In a broad, transformer are categorized in two types, namely electronic transformer and power transformer. Electronic transformer operating voltage are very low and are rated at low power level. These are used in consumer electronic equipment like television, personal computer, CD or DVD player, and other device. In the term, the power transformer is referred to the transformer with high power and voltage. These are extensively used in power generation, transmission, distribution and utility system to increase or decrease the voltage level. However, the operation involved in these two types of transformer is the same. So, let us go in detail about the transformer. Transformer is a static device. That means it has no moving part. It consists of one or more winding which are magnetically coupled and electrically separated with or without a magnetic core. It transfers the electrical energy from one circuit to another by electromagnetic induction principle. I will pass my presentation to my friend.
So we next to relationship between inductance and transformer. If a changing flux is linked with a coil of conductor, there would be an EMF induced in it. The property of the coil of induction EMF due to the changing flux linked with it is known as inductance of the coil. Due to this property, all electrical coil can be referred as inductor. A transformer is a device made of two or more inductors, one of which is powered by AC, inducing an AC voltage across the second inductor. Mutual inductance is where the magnetic flux of two or more inductors are linked so that the voltage is induced in one coil proportional to the rate of change of current in another. For voltage ratio, the voltage ratio is the proportion of primary to secondary voltage, VR. As previously stated, the turn ratio is defined as the ratio of primary to secondary wire turns, TR. You can see that the voltage ratio is equal to the turn ratio by substituting into the preceding equation, TR equal to VR. A voltage ratio of 1/8 means that there will be 8 volts on the secondary for every volt on the main. A transformer is referred to as a step-up transformer if the secondary voltage is greater than the primary voltage. The 7/4 ratio means that for every 7 volts on the primary, only 4 volts is present on the secondary. The transformer is called step-down transformer when the secondary voltage is lower than the main voltage. For current ratio, the voltage in transformer winding is inversely proportional to the current in the windings. Equation below expresses the relationship. Vp is voltage of primary coil. Vs voltage of on secondary coil. Is secondary coil current. IP is primary coil current. We may describe the current ratio in terms of the turn ratio since the voltage ratio is equal to the turn ratio, as shown in equation below. Transformer efficiency. Transformers are very important link between supply and load system. The efficiency of a transformer has a direct impact on its performance and aging. Typically, the transformer's efficiency is between 95 and 99%. The input and output of a transformer are not measured during load conditions since wattmeter reading invariably have 1 to 2% inaccuracies. The copper losses are determined by the currents flowing through the transformer primary and secondary windings, whereas the core losses are determined by the transformer rated voltage. As a result, transformer efficiency is critical when operating at constant voltage and frequency. The temperature of the transformer rises as a result of the heat generated, affecting the life of the transformer oil and determining the type of cooling mechanism used. All-day efficiency of transformer. The efficiency of the transformer has been studied in terms of its ordinary commercial or power efficiency. Because of the load of the distribution transformer fluctuates during the day, it does not provide a true picture of the transformer performance. This transformer is activated by 24 hours, although it only supplies a relatively small load for the majority of the day. As a result, iron losses occur throughout the day, but copper losses occur only when the transformer loaded.
Now, I will continue my part, which is transformer rating and example of transformer circuit intercollection. For the first one, transformer rating. Transformers are designed based on the voltage and current necessary to operate the transformer. They specify this in terms of VA on the transformer nameplate, which is volt amp. It is referred to as a transformer rating. The rating of a transformer can also be referred to the maximum voltage and current that can be supplied to it. There are two types of losses in a transformer. First, constant losses, often known as a core losses, are determined by V. Variable losses, often known as omega I square R losses, are those that are depend on I. As a result, total losses are determined by V and I. Because a transformer rating is determined by losses and losses are determined by V and I. A transformer rating is determined by V multiple with I, sometimes known as VI rating. Because losses are independent of a load power factor, the transformer rating is also dependent of load and can only be determined based on losses. As a result, most transformers are defined in apparent power rating VA and kVA rather than kW. Okay, now we will continue to the example of transformer circuit intercollection. I will give 4 example question. Okay, for the first one, a transformer has a primary coil and a secondary coil with the number of loop of 500 and 5000. Input voltage is 220 volt. What is the output voltage? Okay, now you can see the solution. We use NS over NP equal to VS over VP. Now instead of the information that we have, and the missing one is VS voltage secondary. Now 5000 over 500 multiple with 220, and VS we can get 2200 volt. Okay, for the second question, example question, a transformer has a primary coil with 1200 loops and secondary coil with 1000 loops. If the current in the primary coil is 4 ampere, then what is the current in the secondary coil? Same as example 1, we use IS over IP equal to NS over NP. Instead of the formula, okay, solution is 1200 divided by 100 and multiple with 4. And the answer for current secondary is 4.8 ampere. Okay, for the question 3, based on the figure below, what is the primary voltage of the transformer? Now, the information that we have is VS equal to 24 volt and NS over NP, given that ratio 11 to 1. We will use the same formula, VS over VP and NS equal to NS over NP. 24 volt over VP that we want to find, and 11 over 1, which is 11. So for answer this question is 11 times 24, and the answer is 264 volt. Okay, for example question 4, based on the above table, if the efficiency of both transformer is the same 50%, determine the NS and IP. The equation to find efficiency is VS multiplied with IS over VP multiplied with IP, and the answer will multiply with 100%. First transformer, the missing information is NS. So we insert all the information that we have. So the last step is 200 divided by 2, and the NS equal to 100. For the second transformer, is the missing information is IP. So we will use the same formula. Okay, for information, 50% of efficiency, VS equal to 2, IS equal to 2.5, VP equal to 20, and IP we want to find. Okay, then 0.5 multiplied with 20, we get 10, and the final solution is 5 divided by 10, and the answer is 0.5 ampere.
Next, we go for application of transformers in real world. First, regulating alternating current. The main function of transformers is to increase or decrease alternating current in the electrical system. The transformers enable for better energy efficiency by regulating current flow, which regulates and ultimately lowers electricity expenditures. Second, stopping and starting the flow of electricity. Transformers can also be used in interrupt an electric current or stop the flow of electricity. Transformers are frequently found in circuit breakers, where they use a switch to automatically block the flow of electricity and protect against high voltage damage. For the third application area is battery charging. The operation of generator fuel the concept of battery charging. Transformers are used to regulate the voltage that enters the battery during the charging process. Preventing harm to the internal components of the battery, this is critical since an unregulated voltage might generate significant surge during battery charging. Fourth, manufacturing of steel. Voltage transformers are used in steel manufacturing plants to provide a range of voltage for manufacturing process. During the melting and welding of steel, high currents are necessary, but during the cooling process, lower currents are required. Transformers are required to supply this variety of voltage by regulating current inside the system. Lastly, electrochemical. Electrolysis is generally fueled by the operation of transformers in chemical engineering and manufacturing operation. Electroplating typically involves the use of metals such as copper, zinc, and aluminium. Transformers are utilized to create a regulated electrical current that is employed to drive the chemical reaction from the start to the finish. As a result, the current can be controlled as the reaction progresses. To conclude, transformers has their own function that very useful for use today, especially in the field of electronics. Transformers is one of the most common devices found in electrical system that links the circuit which are operating at different voltage. These are commonly used in application where there is a need of AC voltage conversion from one voltage level to another. It is possible either to decrease or increase the voltage and currents by the use of transformers in AC circuit based on the requirement of the electrical equipment or device or load. In abroad, transformers are categorized into two types, namely electronic transformers and power transformers. The term power transformers is referred to the transformer with high power and voltage rating. A transformer is a static device. That means it has no moving parts. Hence, transformers are very important in this age, and their use is very widespread in the pursuit of world progress. That's all from us. Thank you.